Hi fellas, I'm Sansar Dhakal here, just to help you realize how statistical methods works out. Okay, in this video, I will help you learn about the measures of central value of data and specifically about the mean. Okay, first thing first, what is central value? Well, you see, one of the major purposes of statistics has always been to find a single value that you can use to describe your entire data. What you have to do is to find one single value that can represent your mass of unwieldy data so that your explanation process can be easier. So let's define central value first. So, as the definition says, insert central value is sort of number that you can use to represent entire data. So what are the types of central value, or how can we measure the central values? So you see, there is not a single measure of central value. There are a lot of them, and they represent different meanings. In this series, we will cover just 3 of them, and they are mean, median, and mode. Each of these topics deserve their own video. So in this video, we will be talking just about mean. And if you are not getting the concept of central value as of right now, please bear with me. We'll make these things clear very soon. Mean value, or precisely speaking, arithmetic mean. Well, the term average, which laymen use when used by statistics, is called as mean. So how do we calculate mean? Well, it's pretty simple. I think most of us are even familiar with the idea. So you see, the formula for mean would be sum of values divided by number of values. Or writing in mathematically rigorous term, it is well, this symbol here, it is read as x bar. This symbol here, this E-like symbol, this is called as summation of x. Please be careful, this is capital X. And here n, this is just number of values. Well, if these formulas are not making sense to you, now we will look at an example, and hopefully that will clear up your idea of mean as well as central value. Well, we have a very simple question here. It's quite trivial. The question says there are 3 persons, say A, B, C, and person A earns 10 bucks, B earns 30 bucks, C earns 20 bucks. So you have to find the mean income. That is, the question would be, actually the meaning of this question would be something like this. If these 3 persons were to divide their income equally among themselves, what would be the share of each person? To solve this problem, what you do, you'd first find the sum of their income. Now the total income, you can represent this using this particular symbol. This is 10 plus 20 plus 30 is 60. Number of people, and this is 3 people. Therefore the mean value would be, oh sorry about this, it is capital summation of x upon n, and you would get 60 by 3 would be 20. So the mean value, the mean income of each person would be 20 bucks. Well, what mean is doing is kind of leveling out things. Well, here you can see B has earned more than 20, A has earned less than 20, and C has earned exactly 20. What it is doing is it is cutting off the extra part of larger values and giving it to smaller values. So that's it for general idea of mean. But there is a different approach, a different way how you could have solved this problem. And here is how you could have solved this problem. Okay, another way to solve this problem would be something like this. So what you would first do is just assume, suppose you don't know what the actual value or what the actual mean is. Then what you can do is assume, let's say the mean is 15. We don't know, alright? We don't know what the mean is. Then what you can say is something like assumed mean. Let's say assumed mean is 15. So now what you have here is formation of small x. That is, the deviation from the assumed mean would be, you can add up the numbers and what you will get is 15. So we have a new formula. I will explain this shortly. So now you can see, in this case, you can see within our calculations, our values, our answers are actually same. In the previous question also we got answer 20, and now here with a different method also we can get answer same. But how can we actually say that no matter what, in every single question we are going to get the correct answer using this formula as well? So let's prove this formula. Let me rewrite the formula once. Where we have done just a similar problem right before, so hopefully it won't be much of a problem. But I want you to see here what it says is, suppose there are certain number of values, say there are x1, x2, x3, x4, x8. So according to our original formula, that is, and this equals to x1, x2, x3, the real number of terms. Now, as our formula says, we are going to subtract a from every single one of these terms. Now I want you to see, we have subtracted n number of a's from each x. So therefore, we have to add n a. Now we have defined this term is xk, that is, it would be now small x1, small x2, now first we will get so this is how we get another formula for mean. Let me explain again. If there are certain number of values, say x1, x2, x3, x4, just like we had income before, if there are n number of such values, then what we can see is, according to our definition, original definition, the mean is defined in this way. We first sum up all those values and divide by the number of values. And afterwards, what we are doing is here is we are subtracting a certain number. We don't know what the actual number is, but we are just assuming a certain number. Anyway, it's our guess. We should try to make guess near as accurate as possible. And afterwards, we subtract each the number, the assumed mean from each of those terms. And after subtracting from n is, to make it equal to the previous term, we have to add n number of a's again. And when you define this deviation from the assumed mean, it's x, small x, then it would be something like this. And after simple calculation, we get to this formula. Hope this is clear. So there is a simple question: why will we be using this formula? The previous way was much easier, wasn't it? we didn't have to make a sort of table. So why should we be doing this? Well, there is a very good reason to do so. Normally, we would not always get simple data that can calculate easily. In actual life, in actual statistics, the problems are way too big. There are thousands of data, and you cannot just go on adding all those numbers. It would be too much tedious. But if you make a very good guess and you start calculating, things will be much easier in this way. It just helps you to make calculation easier. Hope this works. Okay, now we will look at different kind of problems, and this is all about the derivation for mean. Okay, now here we have another problem. The problem is something like this. Okay, you have a class where students get a lot of different types of marks. The number of students who scored 20 marks. Alright. Similarly, 12 students scored 30. 20 students scored 40. 10 students scored 50. 6 students scored 60, and 4 students scored 70. Now our job is to find the average marks. How do we find them? According to our formulas. According to our original formula, we know summation of x upon.
This is the formula to solve problem.
But so what are we going to do? Are we just going to add these marks? Well, that is not going to be enough, because we know 20 comes its time, 30 comes 12 time, because 12 students are going to be involved. So in this case, our formula transfers.
Now I want you to observe very carefully, because now we are going to add 20 8 times, because 20 is appearing 8 times. And similarly 30 will be added 12 times, because 30 is coming 12 times. Similarly, we will add each number, the number of times they are going to appear. Adding all these numbers will be very tedious. So instead of writing 20 plus 28 times, we will just write 20 into 8.
Wait, instead of that way, 20 times 8. Because we know 20 is going to appear 8 times, right? Similarly, 30 into 12, and so on and so on, and finally divide by the total number of students. Now we know the total number of time the values are appearing would be some of these numbers, and that would be 60. So we just have to find this value. So our formula is slightly modified for this kind of condition. Instead of writing just x, we will write fx. That is, first we have to multiply x by f. So now we will slightly modify our table to get the value of fx. You can do the calculations yourself, they are pretty trivial. You are just multiplying 20 by 8 and getting 160. And I hope we have properly understood why we are multiplying here. And after do all of this, now you can directly put the value over there. So 2460 divided by 60, and the answer would be 41. So now here is the homework for you. Now I want you to solve this problem by assuming that mean would be well, let's say instead of 41, what about considering 40? You will consider that mean is 40 and solve this problem using a similar formula. That will be now I hope you understand why we are doing the same thing. I want you to do this same problem in this way. Alright, this much for this kind of question. Now we will look at third type of question. Okay, in this question, instead of having exact marks, what we have is the number of students securing marks between 0 to 10 are 5. Okay, excluding 0. This does not include 10. Okay, this part does not include 10. These 5 students have not secured 10 marks, alright? So what this question asks us is to find the mean value. So alright, before what we were doing was we were multiplying this number by this number of students. But in this case we don't have exact marks. So we assume that the marks are equally distributed in between. So we are going to take a midpoint of this number. That would again be a kind of like taking mean. Okay, now the midpoint of 0 to 10 would be 0 plus 10 divided by 2 and you would get 5. Similarly, you can get here 15, 25, 35 and 40. And rest are quite similar. Now here, what we have done is we have first of all find the midpoint. Since we don't know what is the actual marks, we are just assuming that marks are equally distributed and we have found the midpoint. And afterwards, we are multiplying this by number of students and we get FM, and finally we find the sum of FM. And afterwards we find number of students by adding all these numbers. Afterwards, putting values in the formula, we usually get the mean is 33. So hopefully this is making sense now. Okay, I want you to solve this problem as well by using the formula, another type of formula, as I mentioned before, a plus summation f. Okay, this says x by n. So in this case, you will be doing the same, but using a different way. And you can use assumed mean to be 30. Give it a try. So this much about the continuous study. Okay, at the end of the video, now I want to talk to you about another formula that is quite important, I would say, and some other properties of mean that would be very helpful for you in the future, in the coming videos for other statistical. Yes. All right. Well, this next formula is about the finding the mean out of mean. Okay, suppose you have data A. Just like we were making tables before, that would be some sort of data, and apart from particular table, you obtain a data that would be x bar is, let's say, something 33, and number is 100. So from another set of data,
For the sake of simplicity, I have written 100 as 90 to make calculation a bit easier.
alright. Okay, from data A, we have 33 people. No, sorry, we have 33 mean value among the 90 of such values. From data B, we have mean value of 10 from 10 of such values. So now question asks us to find the mean value among these two combined. So now what we can do is we are supposing this to be 1, sorry, this will be 2, this will be 2. Now we have another formula that is I will shortly explain where this formula comes from, but for now, bear with me.
We will just solve this problem.
Okay, where does this formula comes from? Now we will look at that. I hope I have made clear on how to do this problem. You are multiplying these numbers simply by putting the values in formula. But now let's look at where this formula comes from. So, I have rewritten the formula for once. Now let's. So we all know the definition of mean is the summation x by n. So for first set of data, we are giving symbol that mean of the first data is sum of the first values of the first data divided by the number of the values of first data. And when you multiply n by x, mean, when you multiply n by the mean, what you would get is summation of the first data, which would be something like this. And in similar fashion, you can easily get that when you multiply the number of the values of the second data times the mean, you will easily get it would be the sum of values. For sake of simplicity, I have used
X
a
prime
symbol here, and when you put all those values, what you will get is now. As you can see, when you add all those terms and divide by the total numbers, that is total number of values, you would come to the very original formula, which makes our point quite clear. And hopefully from this, I hope you can see why we are using this formula. Okay, I guess this much it is for today. And in the next video, we will learn about the medians. Medians are quite important. And okay, one more thing before going. There are some properties of mean that I want you to work out for yourself. That is, when you just like when we are taking the assumed mean, as you can see there, if we had actually assumed the true mean, then we had got those deviations value to be 0. To put it simply, mean is such a number which produces the least deviation, that would be 0 deviation from all. Okay, this is another very fascinating property. I want you to try solve these two features all by yourself, and if you have any problems, I'm always here to support you. If you think I should make videos on these two topics, these two properties as well, I'll surely help you. But first, I want you to try your best to find proofs or in certain way a certain level of understanding of these two properties, because in the future we are going to make a lot of use of these two properties. And that's it for today, I guess. I hope you are enjoying these lessons. So thank you for bearing with me, and if you want to get more videos on statistical phenomena in statistics, please encourage me, and your encouragement is the one thing that will keep pushing me to make better videos. I'm novice to YouTube stuff teaching, so I'm trying my best. There might have been some mistakes, and I want you to improve me as much as you can. Thank you.